Hello everyone, this is Shraddha Bhurre from IIPLC Indore, and today we'll discuss some topics related to numerical analysis and design, system of equation, algorithm to evaluate polynomial, straightforward determination, nested parenthesis method, and algorithm to find cube root of a number by bisection method or false position method. So our first question is to develop an algorithm for solving following system of equation to find out x and y for given values of a, b, c, p, q, r. Assume that these are non-zero. So our equation is ax plus by equals to c and qx plus qy equals to r. Now, first the logic part that leads to the algorithm given equations are this. From equation 1, we get x equals to c minus by upon a. Now, substituting this value of x in equation 2, we'll get the value for r as p into c minus by upon a plus qy, or q minus pb upon a into y equals to r minus pc upon a. This is equation number 4. Thus, if we compute q minus pb upon a and replace the value of q by it, and compute r minus pc by a and replace the value of r by it, we have qy equals to r and y equals to r by q, or y equals to r by q. We now substitute the value of y in equation 3 and find x. In this way, we can find our value for x and y. Now, algorithm for this, first step is read 6 numbers and assign them respectively to a, b, c and p, q, r. Now, second step is to compute q minus pb upon a and replace the value of q by it, and next compute r minus pc upon a and replace the value of r by it. Now, our next step, if q is 0, then write no solution and stop, else will continue. Then y equals to r by q and set x equals to c minus by upon a, and write the value for x and y. This is our answer. Now our next question, for dry run this algorithm for the equation of problem question 1 with the following value of a, b, c and p, q, r. These are the values for a, b, c and p, q, r. Give the answer correct up to 4 decimal place using floating point computation. Illustrate situation of ill condition equation with change in coefficient q equals to 2.6060, why the situation has arrived. So we have to give the reason why our answer varies when we change the value for q. Now assigning value. First, the values of a, b, c and p, q are this. Normalized value for floating point computations is for a is 0.2500 10 to the power 1, for b is 0.5200 10 to the power 1, for c is 0.62000 into 10 to the power 1, for p is 0.1251 510 into 10 raised to power 1, for q is 0.26050 into 10 raised to power 1, and for r is 0.31520 10 raised to power 1. These are the normalized value for floating point computation. Now we can dry run our algorithm by these values. Now substituting values for p, b and a, will have 0.2606 as value of q. Now compute r, pc upon a, we have 0.1192 as value for r. Q is not equals to 0, thus will continue. So our y will be r by q, that is 0.1666 10 raised to power into 10 raised to power 2, and our x going to be minus 0.3217 into 10 raised to power 2. In this way, we have our value for x and y, and our algorithm works. Now, when value of q is changed to 2.606 on calculating value of x and y with changed value of q, while all other variables are kept same, x equals to minus 0.2352 10 raised to power 2, and y is 0.1250 into 10 raised to power 2. Thus, a change in one coefficient by less than 1 has led to change of more than 30% in the value of x and y. Such a problem is said to be ill condition, that is when we change our value for given value for q, that is we have done a slightly change in value of q, will have the 30% change in value of x and y. Reason as to why the situation arises. So reason is, in this case, the reason for this last sensitivity is due to the fact that the straight line respectively, the two equations are almost parallel, and a slightly change in the slope of one of the straight line drastically changes their point of intersection, which is the solution of the equation. Now our next question is to write an algorithm to evaluate the given polynomial. So for this, given polynomial is can be written as a0 plus a1 into x plus a2x square plus and so on up to an xn. We have written this polynomial as a0 plus a1x plus a2x square and so on up to a0xn. This is called forward determination. This algorithm is based on the following alternative method of writing expression as this. Now in the next step, our x is common in this terms. So and in next step, from this term we can get x common. This is called as the next step parenthesis method. Now algorithm, first we have to read the value for x and n, and the next step we have to apply the for loop from I equals to 0 to n in steps of 1. So in this way we can read our ai. Now our next step is to compute p as an for and after that we have applied for loop for I equals to n to 1 in steps of -1. Then we'll compute ai minus 1 plus x into p. Our p will change at any at every steps. So here our for loop ends, and at the 7th step we can give our answer for p. That is, we have our polynomial as this. Now our next question is to obtain the recurrence relations for dividing a polynomial px and write algorithm for corresponding polynomial division by x minus r. So we have to divide our polynomial by x minus r. So here is our polynomial, and we have to divide it by x minus r. So we can see our first term is an x to the power n. So we can divide it by our first term an x to power n minus 1. So our term will going to be an and x to the power n. So this term will be eliminated, and our term will going to be an minus 1 plus r into an into x to power n minus 1. In this way we can get our this answer, that is an x to power n minus 1 and so on. If we call the reduced polynomial bn minus 1 x to power n minus 1 plus bn minus 2 x to power n minus 2 plus and so on up to b0. So then equating the coefficient of above polynomial with the quotient obtained by division above, we get bn minus 1 equals to an, that is this an is equals to bn minus 1, and an minus 1 plus r an is bn minus 2, that is this term will be bn minus 2, this term will be bn minus 3. So we can see that for compute the value of bn minus 2, we have to first compute bn minus 1, that is this. So after that we can calculate the value for bn minus 2, and same for bn minus 3. If we compute the value for bn minus 3, first we have to compute the value for bn minus 2, and in this way we can find all the terms. So in general we can write bn minus I plus 1 equals to an minus I plus r into bn minus I. So algorithm for this is, in first step we have to read our ai. So for this we have to apply for loop from I equals to 0 to n in step of 1, and Now next step, we have to compute bn minus 1 as an and in the next step we have to again apply the for loop from I equals to 1 to n minus 1 in steps of 1 for computing b n minus 1 I plus 1 equals to a n minus I plus r into b n minus I. Now at the next step, again we have to apply for loop from I equals to 0 to n minus 1 in steps of 1, and at last we have our computed value for b. Now our next question is to calculate the value of polynomial for x equals to 4.0110 using floating point arithmetic with 4 mantissa using two approaches. First is straightforward determination and second is nested parenthesis method. We have seen this method before, so we can easily apply these methods here. So our polynomial is x cube minus 4x square plus 0.1 into x minus 0.5. In straightforward determination, we have to directly apply the value of x in this polynomial. So we have our answer is 0.781 into 10 raised to power minus 1 for straightforward determination. And for nested parenthesis method, we have to collect the common term, that is x, from here, and after that we can substitute the value for x in this, and we have our answer 0.1846 into 10 raised to power 2. So by this we can calculate our error as E calculated minus E actual upon E actual. So by substituting these values, that is E calculated is 0.1846 into 10 raised to power 2, that is this value, and actual value is 0.000781 into 10 raised to power 2, and again our actual value. By this we have our error term is 0.9957. Now our next question is to develop an algorithm for find cube root of any number using bisection, false method, secant method, or successive approximation. So we are using here bisection method. In this method, we begin the iterative cycle by picking two trial points which enclose the root. 2 points x0 and x1 enclose a root if f of x0 and f of x1 are of opposite sign. Remember, if these 2 points are of same sign, then our root doesn't lie between them. So we know bisect the interval. So now bisect the interval x0 and x1 and denote the midpoint by x2, so that our midpoint can be represent as x0 plus x1 upon 2. Now our algorithm for this is, first we have to read the value for x0, x1 and our error term, that is we assume here error term is 0.0001. So, and second step we have to compute the value of y0, y1. Our y0 is the function value at initial point and initial point of our interval, and y1 is the function value at the last point of our interval. And at fourth step we have to initialize our I as 0. Now we have to check the sign for our given values of our function. We have so now if the sign of our functions is equal, then our starting values are unsuitable. Our root doesn't lie between that interval. So while x1 minus x0 upon x1, mod of this is greater than e. If mod of this is greater than e, so our value for x2 is x0 plus x1 upon 2, and value for y2 is function value at x2. Now we have to increment I by 1. At the next step, if a sign of our function is equal, then value for x0 is x2, else if our value for our function is opposite, so value for x1 is x2. Now at the end we have to write solution converges to root if our if our obtained value is less than e, and we have to print the number of iteration in which we will get the root, and at last we have to print the value for x and y. Thank you for watching video.